Awesome. So I think we can get started. Today, as the topic just says, we are going to speak about Amazon EKS security. EKS, of course, is one of my favorite topics, and security is always super important to make sure a successful adoption with our customers, right? And then I have the following agenda where I'm going to cover basically four major points in order to be successful. So we are going to get started with some of the container challenges. We're going to explain things we usually see while working with our customers and how to properly tackle them for a successful adoption. Then we're going to drill down into some of the EKS security best practices, followed by some tips and tricks around observability and how we can use AWS services as well as some third-party solutions for threat detection, right? So let's go to the chase. When you're speaking about container challenges, of course, there are multiple things that can come up to your mind. For example, process is usually running on a shared host, isolation implemented by Linux namespace, C groups, and so on and so forth. Immutable and shorter time to leave ephemeral containers. On top of that, some of those traditional legacy security software, most of the time they are not container aware. Speaking about firewalls, IDS, IPS, and some other solutions. Then it turns out to be complicated to overcome and to provide with a reasonable solution to address all of these challenges, right? But the purpose of this conversation is to give you some insights, ideas, and tools you can use while engaging with your customers and thinking about security, thinking about ways to implement security for a successful project implementation of EKS and containers overall. So thinking about defense in depth, right? So there are multiple ways to tackle this and using the onion approach is one of the ways that I like most, because when you are preparing your containers with a Docker file and you are deploying your container and you are preparing your container, there are multiple things like you have the user data, configuration, source code, dependencies, container, and the host that will be we're going to be running that. So using this approach is the one that I like most. And there are some mechanisms to secure the host in which the containerized applications we run. Then comes the security that relates to the container imaging and runtime. Also, you need to think about things like logging, networking, and for sure, the way you're going to be working with the host where this application and this container is going to be run. So things you consider, right? The host you're going to be using, the type of Linux distribution, things you consider like Linux packages, leaks, and some regulatory things related to the way you're going to be publishing your content. Then it comes the runtime standards using OCI, immutability of images. All containers share a kernel, and you need to think about things like scanning your container, necessary privilege for users, access to the underlying services, syscall, and so on and so forth. on top of that, you need to think about ways you're gonna provide code analysis and the source availability, right? So the types of languages, use surface. So you need to consider this. On top of that, you need to sanitize user inputs. You need to provide things like static code analysis, and you need to think about ways to protect your credentials, API keys, and last but not least, you need to think about the business core data and the user data that we are going to be using, right? So overall, these are the things we are going to be covering throughout these sessions. So I'm going to drill down into to provide some tips and tricks on how to overcome and to get around issues. And let's start by discussing the container security top 5, right? When you look at this, first and foremost is that you are trying to keep your container safe to avoid surprises, right? And these are the top 5 areas where you need to be focused for a successful implementation from the security perspective. First one is about container imaging and supply chain security, right? In other words, your pipeline and DevOps implementation for the overall process of creating your container. So let's drill down into this. When it comes to container images, first and foremost, you should know what dependencies you are putting in your containers, right? If one of them is vulnerable, your whole container is going to be vulnerable as well. And then to avoid issues, you may, for example, scan dependency manifest with some AWS toolings like AWS Spectre and ECR and some other third-party tools that I'll be explaining in a few minutes. For example, you may alert when upgrades are available, and you may block. You must block releases if they contain critical vulnerabilities. So these are the key tips you need to consider when you are thinking about container images, right? And on top of that, what I would recommend, of course, is to use the minimal-based images such as Scratch or distroless, because they eliminate and they remove binaries that are not needed at runtime. So basically, the concept behind these tools is that they are very popular in the world of container, and pretty much the idea is to package applications in container images while at the same time removing as much of the operating systems as possible, right? So for example, unneeded package managers, libraries, shells, and so on and so forth. So basically what this approach will provide is that they will provide some security benefits. For example, as size is one of the most important things when it comes to attack surface, right? So in other words, the smaller your container is, the better, right? Because your attack surface is going to be smaller, and then that will decrease the chances of your container to be exploited, right? So this is one of the recommendations also. On top of that, one additional recommendation that I usually see while working with containers is to use multi-stage builds to make using distroless images easy. So one of the things so for those of you, you're maybe probably familiar with this, but one of the most challenging things about building those images is to keeping the image size down, right? So whenever we use Dockerfiles commands like run, copy, add, and so on and so forth, that's going to add new layers and you need to remember to clean up all the artifacts when you don't need them anymore, right? And using these multi-stage builds, you can use multiple from the statements in your Docker file, which streamlines the overall process. And basically, each from instruction can use a different base, and each of them begins with the new stage of the build, and you can just reuse. The purpose of this is to make to streamline the overall process, and you don't need to do some magic with a shell to reduce the size of your container, and this is really one of the recommendations as well. For example, here, container image layers, right? So we may try to reduce as much as we can, because as I just said, the more commands you have in your Docker files, the bigger will be your overall image, right? So, and our goal is always to minimize the size of an image. So try to reduce as much as you can. On top of that, it's always good to link your Docker files. So there are several tools out there that can be used. Lint is one of them. And for example, when you run your Docker file against one of these tools, it provides some recommendations and some observations on the way you are developing your Docker file, right? For things like, for example, the first one from Debian, always tag the version of an image explicitly, right? So we are not doing this in this Docker file, and of course, this is not following the best practice. And doing and linking a Docker file will help to identify where the issues are. For example, expose 80,000 ports. So this is something that is not available, right? Because valid Unix ports range from 0 to 65,000-ish, right? So these are the things that we usually recommend to prevent users from creating Docker files that are not following the best practices. And as a next step, and really super important, is the container supply chain or your pipeline for creating. So you can see basically as three major steps, where the first one is software development and container image creation, using some of the techniques and some of the tips I just provided. You have also the container image curation and the execution, right? So we have isolated these three steps into trusted tiers, right? But most important, and the thing that I wanted to mention is that whenever you are designing your system, they need to be recreated easily, right? In other words, you must use infrastructure as a code to ensure you can tear down and rebuild your environment with little overhead. On top of that, you need to automate the build and deploy process. So in other words, the less manual process you have, the more consistent your security will be. And ideally, the only manual action is basically code review and approval to merge your work, your source code in the main branch of your code base, right? So these are the typical things we need to consider. And also, of course, and as a reminder, your base image matters. So you must choose your base image based on your application, not the other way around. So, and on top of that, just a few other recommendations. So you, of course, you need to perform static analysis of code, which is performed usually within your CI pipeline before the container image is created. again, as mentioned, no sensitivity data within the image. So for example, to store, you can have secrets or credentials in your container, and then you need to mount these secrets in memory at runtime. Also use immutable tags, scan container for images for vulnerabilities, and of course we're going to be drilled down to some of the options, and never forget to sign container images. So this is the rules of the thumbs for sure, but we are going to drill down into some of the things to be able to accomplish this. For example, you may use Amazon ECR, which is a fully managed OCI compliant container registry. And actually, it implements many of the best practices that I just mentioned, right? You can configure, for example, ECR repository to be immutable to prevent image tags from being overridden. You can manually scan container images stored in Amazon ECR. There is the out-of-the-box functionality, and also you can integrate this with Amazon Inspector. I'm gonna explain more the details in just in the next few slides. You can integrate those Amazon ECR events to Amazon Event Bridge when an image scan is completed, so you can automate the process of scanning and to identify potential risks or issues with your with your scan image, right? And you can create lifecycle policies with one or more rules using this. For example, as I just mentioned, there are the basic scanning out of the box, which is free. We use the Clear open source engine. And also there are some enhanced scanning, which is powered by Amazon Inspector, where you can scan on push and continuous automated rescans. I'm going to explain to all of you what the process looks like, but basically you can integrate with Event Bridge, and you can send notifications to automate the overall process rather than just do that when you push a new image into ECR. There are dozens of data feeds to generate CV, common vulnerabilities, right? Finds. And it's natively integrated with Security Hub, Event Bridge, and AWS organizations. In this example, I just brought this just to understand what the process look like to automate everything. So we are setting up a continuous scanning in Terraform for ECR. So basically, once enabled, when a container is pushed to ECR, a scan is triggered in Amazon Inspector. Then once the scan completes, the results are published to the Amazon Event Bridge, and a rule in Event Bridge sends that message to an SNS topic, and then that message is posted and can be sent to multiple subscribers, such as emails or Slack messages, right? As you can realize in this particular configuration, Inspector is setting up for continuous scanning of ECR, which means that the scans trigger not only when an image is pushed into ECR, but whenever a new common vulnerability or exposure is added to the database, which is really, really important because we are continually making sure that the existing images are following the best practices and the standards. And as I mentioned, there are some third-party tools. Some of them are there are open source tools for sure available out there. But let me pick up one example here. So we can use, for example, one tool from sysdig, which has a file call, and you can monitor system calls that are indicated of compromise. For example, you may have some alerts indicating that sensitivity file, a sensitivity file was just opening for reading by a non-trusted program, right? According to your Docker file and your Linux configuration. So you may use these tools to make sure all your runtime policies are used, and you have file integrity and whitelisted and only whitelisted users. So these are the common examples we can use to make sure the container image is secure. So in a nutshell, these are pretty much the recommendations when it comes to image security best practices, right? So less is more. As a reminder, no secrets within the image. Just follow the 12-factor app, and don't place a configuration in container images for sure. Only use scan, signed, and trusted based images, and of course you can leverage some of the techniques that I just described in the previous slides, and only run one service or process per container, and never include troubleshooting tools or console tools like Bash or SSH within those images. This pretty much summarize this particular area. And then I wanted to spend some time on the runtime security itself, right? So first and foremost, in as much as it's important to secure your container, you need to think about ways for secure the infrastructure and the runtime. So, for example, every container should declare its resource requirements. You need to specify CPU and memory resource to prevent rogue containers from consuming all resources on a host. On the other side, for example, if you wanted to simplify the administration, Kubernetes containers share an user ID namespace with the host by default, which means that the UID 100 inside a container is identical to UID 100 on the host. And the same is true for UID 0, for example, the root user. So by default, containers start running as UID 0, which poses several risks. So we need to think about things we need to have in place for the runtime, to protect the runtime. Other things we need to remember: containers are running in privileged mode with unauthorized users and things like that. So first thing, as I just mentioned, use limited container resources to prevent other containers like rogue containers to take over the whole host and to do things that are not allowed in a compromised entire environment. On top of that, of course, as I just mentioned, never run as root user ID 0. This is the default. We need to set up a few properties and a few configuration to make sure this is not allowed. Also, as I just mentioned, we must use Linux security modules like the App Armor and SecComp to prevent unwanted behaviors. So for those of you that are not familiar, for example, the App Armor is basically a security module that protects an operating system and its applications from security threats. In other words, it prevents an application from accessing files it should not access. On the other side, we may also leverage seccomp, which is also a Linux kernel feature that restricts programs from making unauthorized system calls or syscalls, which reduce the chance that a kernel vulnerability will be successfully exploited, right? So basically, the recommendations is to set up this. For example, we recommend enabling at least this default seccomp profile provided by the container runtime. And this profile at least allows most of the system calls, but excludes some that are considered high risk. So you may consider this as a best practice to protect your container to access your runtime system, your host, and the guest OS. And again, as mentioned, don't run privileged container. And if you do, just drop some of the unneeded capabilities by doing as displayed in this slide. So you pretty much can drop some of the functionalities, some of the things that are not used. Try to set up a time to live for those containers that are considered to be dirty, right? So basically, these containers are the ones that users have executed into then and regarding on a specific reason, and then you need to set up a TTL and a best practice to reduce type-based attack surface the best way possible. One additional thing and recommendation as well from the runtime perspective is to use policy as a code. There are several out there available to restrict what a container can do, right? So we have these pod security policies, which allow individuals and users to restrict pods from specifying security sensitivity properties in the context of the pod specification. We have, for example, OPA, which is an open policy agent, which is a policy engine that allows individuals to define and enforce policies. There is a Gatekeeper, which is an OPA sub-project that provides integration between OPA and Kubernetes. And also we have the third one, Kyverno, which is a policy engine that uses Kubernetes YAML backed by CRD, right? So we have the options out there. The purpose of this is, of course, is not to drill down, but to make sure you are leveraging at least one of these components to enable policy as a code. And last but not least, there is the CIS benchmark standards. You may use these for EKS, for Kubernetes, and for Docker, but we also have made some adjustments to provide some guidance and benchmark on the overall infrastructure. For example, using this, you can using this benchmark to provide guidance on security configurations for a managed Kubernetes cluster, where you typically manage the Kubernetes cluster control plane and the nodes and the data plane itself. So this is a really important configuration. And we have done this also for Amazon EKS. There are some add-ons on top of that. And it provides like a checklist on things you need to be compliant with in order to have a secure Kubernetes cluster with the EKS. And now speaking about the host itself, host security. There are several things you need to have in place, but always consider to use a Linux distribution purpose built from the ground up to run containers. So this is helpful to minimize attack surface. There are some options out there. For example, the AWS Bottle Rocket, Ranger OS, Talos, and so on and so forth. And the upside of this is that they are always all minimal, and they are all updatable. And that can be accomplished creating usually by transactions you can do to update these uh, OS, these operating systems, right? But on top of that, there are some additional recommendations, right? Uh, for example, the AWS Bottle Rocket uses the security enhanced Linux, SE Linux, and is always in enforcing mode. Basically, when you have your Linux system, you basically have two modes, right? Which is the permissive mode, and which permission denials are locked but not enforced, and enforcing mode, which everything is logged and also enforced at the same time. So that's why you should be considering when you're creating your containers with the EKS to use the AWS Bottle Rocket, because it follows these uh, best practices. And from the host isolation techniques perspective, right? So EC2, you are doing this using the hypervisors, AWS Fargate, of course, the serverless compute for Amazon ECS and EKS. You have some additional boundaries, and you use Firecrack micro VM for running these workloads as well as for Lambda. And some of the recommendations here. So remember always to deploy hosts onto private subnets. Use Amazon Inspector to assess hosts for exposures, vulnerabilities, and deviations from best practices. So one important thing, Amazon Inspector can be used for multi-purposes, right? So you can scan your image, you can scan your host, and also you can, it's container aware. I'm gonna explain, I'm gonna give you more details, but this is always a best practice from the host security perspective. And also when it comes to networking security, here are some of the things you need to consider, right? Uh, AWS security groups around container hosts, use Amazon EKS security group for pods, set up pod level network policy to prevent unauthorized network traffic from to ingress pods, use Kubernetes network policy for east-west traffic within the cluster. Start with a deny all policy to isolate pods, then incrementally add policies, right? So these are the key things you need to consider when you are setting up. For example, port 53 domain with a DNS to kube system. So you need to do uh, use this configuration as a best practice from the security perspective. And now when it comes to access control and auditing, as a general guideline, always, of course, practice the principle of least privilege, set up a EKS cluster endpoint to be private, and perform audit access to the cluster on a regular basis. And from the IAM perspective, block access to EC2 metadata and use IAM roles for service accounts to assign AWS identity to pods. Those are pretty much the overall recommendations from the security perspective. And for those of you that are not familiar with, there is a comprehensive guideline available at GitHub where you can identify most of the things I have described here, as well as some additional things. So we have this extensive and comprehensive guideline which provide security best practices from different lenses like networking, data encryption, infrastructure, image security. So basically, I try to summarize everything, but this is a more comprehensive, and you can learn more from this, right? As a next step, observability. This is also an important piece of security monitoring your overall environment. And of course, there are the most common solutions, right? CloudWatch logs, CloudWatch metrics, X-ray traces. So depending on what you are trying to achieve, so one provides representation of metrics, the other provides some insights on the things that are happening, and also the X-ray provide a view from the inside out, and provides visibility into both the path that a specific request is happening to identify security issues and potential areas that needs to be improved. So providing insight. With this in mind, we have, for example, the CloudWatch Container Insights, which is an add-on on an extension that is container aware and can be used for both for all of the container offerings like ECS, Fargate, and EKS on EC2. So basically collect, aggregate, and summarize metrics and logs from all of these containerized applications, and you can use this integrated with all the other workloads. And also remember, we also have the CloudWatch Container Insights for Prometheus, right? This is another thing. So we have this view where we have this agent that can be integrated with the Prometheus SDK for no matter the solution that we are using. This could be used to provide some insights. There are also the CloudWatch logs for Amazon EKS integrated with CloudWatch, but remember that the same could be achieved using FluentBit, right? So it's the same thing, but rather than rely directly on the CloudWatch and EKS providing this view into the CloudWatch, we are leveraging FluentBit-based logging with EKS in Fargate, for example, and you may integrate with existing monitoring tools like Splunk, Datadog. You may integrate with Kinesis firehose and integrate Elasticsearch, OpenSearch, and so on and so forth, right? Generally speaking, you may implement AWS services for monitoring for your cluster from different perspectives, right? So you have the AWS native monitoring service using CloudWatch, container insights, synthetic contributor insights, and on the other side, you can go with those open source offerings using Amazon Managed Service for Grafana. You can do yourself by picking up one of these options like Amazon Elasticsearch or Amazon Managed Service for Prometheus, or even using some of the other open source options available out there. So No matter the type of the monitor offering, we have different. You may go with either AWS native monitoring services or open source managed service, right? So this is really important to remember because there are multiple ways to accomplish the same task. And now it's really important to understand ways to be proactive when it comes to threat detection, right? So we spoke about ways individuals, attackers may be exploiting a container image or a host or your networking or your cluster, whatever. But what are the ways we have to automate and to do this in a streamlined through a streamlined process? So what are the best practices for securing container workloads running on AWS? Before we can cut to the chase and we can drill down into some of the options, it's really important to understand the difference between the traditional threat detection system versus what we are going to understand. What are the challenges we may face with this security information and event management system? They are pretty much difficult to detect malicious patterns. You may need to create complex query for data sets that are most of the time they are disjointed, right? Sometimes you have complex infrastructure set up required to implement all the agents and to be able to collect those things, and which can we can result in things in a situation where you don't have real-time alerts provided out of the box. So these are the typical things we may see. And one of the key components, of course, you may also one of the things that you can be thinking about is to use GuardDuty, right? And also, this is one of the key components to be able to automate cluster threat monitoring, right? So it monitors VPC flow logs as well as DNS logs, Amazon EKS audit logs, and it integrates also with Amazon Inspector, and it provides an overall view on the things you may implement. So basically how it works behind the scenes under the covers, right? You may think of Amazon GuardDuty to collecting from multiple data sources, as I just mentioned, and also it has the capability of collecting control plane logs without any specific configuration and without any instrumentation, right? So you basically turn on GuardDuty and you may leverage this. And there are basically two things, right? The threat intelligence, where it has some fighting types. For example, command and control activities or a specific risk, or eventually unusual user behavior, unusual traffic patterns, right? Analyzing all of these logs, it provides the findings, which it categorized as high, medium, and low based on the severity. And then you may integrate with this with Security Hub. It provides alerts integrated out of the box with other partner solutions, or you may use the Amazon Detective, right? So this is the way you can do. But let me explain a few ways you may use this, right? So I wanted to highlight a few different ways you may consider using GuardDuty and its detections for EKS audit log. So think about this. You have a deployment pipeline, AWS code pipeline, and GuardDuty has integrations in place with all the log file sources that supports that supported GuardDuty to consume and process all of this. So again, as I just mentioned, you don't have to turn on log sources in order for GuardDuty to be able to ingest the logs and produce its detection, right? So it's basically this whenever you enable this into that particular account, um, all the environments are providing these. They are enabled. Then GuardDuty can collect those metrics and those insights from the logs. If, for example, if you have this deployment pipeline where you are deploying EKS cluster into non-production environments to confirm the deployments are working, then you can enable GuardDuty to in those environments as well, right? So no matter the environment you are working with, you can enable this, and let's say you are using Terraform or CDK to automate all of this process. So whenever you are setting up and spinning up your environment, you may integrate and provide this insights to GuardDuty. And on top of this, logs collection, you have this function capability within GuardDuty, which goes by the name of malware protection, which basically is a fully managed malware detection service within AWS. And the good news is that it's a container aware, which means it can detect the malware files on EKS, for example, on your container running on EC2, which allows customers to investigate the exact container that is compromised, and you may fix the issue. And the good news as well is that no security software required for this, so it's agentless. So let me look at the example provided right here. So basically, the screenshot on the left side indicates GuardDuty Kubernetes finding where the system detected a suspicious API call made to the EKS cluster from an anonymous user. And the API is tied to the discovery phase of the attack. You may understand this is commonly a result of misconfigured cluster, right? And then, for example, 1 hour later, we see an EC2 instance running an EKS cluster communicating outbound to a Bitcoin mining IP address. So looking at these files, some common questions that occur that may happen to customers is the instance compromised? Is the container cluster running on the instance compromised? Is there a piece of malware dropped due to the suspicious communication? There are multiple things that customers may be considering. And the good thing with this is that you can use these findings to provide insights for the customers, and to address all of this. We build this feature to help identify all of these problems, right? To detect threats originated from containers, compromise attacks, and so on and so forth. And as just mentioned, there is the possibility, out-of-the-box integration between Amazon Detective, which is integrated with Amazon GuardDuty. And one important thing to remember is that you may consolidate Amazon GuardDuty and Amazon Detective from all accounts into one. You don't have to have disparate and scattered logs across different accounts. You may consolidate everything in a single account for the security purpose. And on top of this, I wanted to provide more insights on how the Amazon inspector scans container images, right? For example, it retrieves the image from the ECR, then extract each layer of the image, then look at the OS and installed packages, look at the OS and the installed packages through the files, compare against a vulnerability database. And this is the way it operates. So it's really important to understand this. Again, as I just mentioned in the previous slides, you may automate this and provide notifications for images scanned. So you may push events to Amazon Event Bridge, then integrate with Amazon Inspector. You can start the scan and then provide information. So all of these steps may be automated, and everything is managed by AWS. So you don't need to create a specific instrumentation to achieve this. And looking at the pipeline perspective, so let's say you have this implemented within code pipeline. So have the source, and then when user is going to push a new version, then the source code is pushed, then you're gonna build a new image. Then the next step is to scan for containing vulnerability assessment. But what the process should be in order to automate this. So git push, then this triggers the source, right? Then the third step is to publish the source, then the build, which will publish something into Amazon ECR. Then the fifth step is to integrate with a notification. You can send this to multiple subscribers. One of them could be a Lambda function, which will trigger the pipeline approval. And then the sixth step is to have this integration with Amazon Inspector, which will trigger a Lambda function, and this pipeline may integrate with the Amazon Inspector to determine whether or not you're going to approve this new image from the security perspective. So you're automating all the steps of a DevSecOps using all the available tools. And also, of course, you may integrate with some third-party tools. So this is one of the ways and one of the approaches you may be using to provide security in the pipeline, right? And then finally publish this into ECS, EKS, whatever. So, and what the Amazon Detective for EKS look like, right? So it integrates with GuardDuty, as I just mentioned. It identifies root cause for potential security issues against using some of the Kubernetes activities, Kubernetes API calls, and it provides a unified view and interaction with the cluster over time. And ingest EKS audit logs by integrating with the Amazon GuardDuty. So this is the overall features we have out of the box. But if you wanted to combine all the things into a single diagram, you're gonna find that we have the Amazon Detective, Amazon Inspector, Amazon GuardDuty, and there are some functionalities out of the box to provide a single view. So the EKS protection within GuardDuty, malware protection as well for EC2 and EKS. We have Detective EKS investigation within Amazon Detective, and Amazon Inspector with ACR support. And everything may be used for continuous monitoring within Security Hub. And you may provide an automated response with existing and some third-party tools.
Well,
That's all I had to share. Hopefully you have enjoyed this session and see you in the next one. Thanks for watching. Bye.